good afternoon, everyone, and welcome to our talk. My name is Stefano Zanero. I'm an associate professor at Politecnico di Milano. In my life, I had the bad idea of founding a company called Secure Network that is one of the leading penetration testing companies in Italy. And Roberto, with me, has been my student, has been so unfortunate that he took a job at my company. Together, we are going to present on the night of the living vulnerabilities. They are coming back, ladies and gentlemen, from the grave, and they won't stay dead. And we asked ourselves why the vulnerabilities in IoT are so much alike, vulnerabilities that we thought were dead and buried forever. And so when we started looking at devices, we found funny devices on IoT.
When we talk about IoT, we are just used to the acronym IoT, but we don't always think about what it actually is. And if we took a look at some of the devices, so we found that you can have smart hairbrushes nowadays, which are...
Roberto immediately.
Yeah, and I haven't personally tested them because I can't, but in general, they are supposed to help you understand the health of your hair, apparently, which is something you should really do. Then there is the smart wine bottle. And I think the trick there is that at the end of the night, it's going to be smarter than you if you use it enough. So there's that. And then there are just some other things that I can't find the use for. For example, a smart egg tray that just is smart and is an egg tray. And a smart salt shaker and grinder that doesn't grind the salt and it actually doesn't shake it. So we have also that.
But it's smart.
But it's smart, yeah. And since I took a look at them, I just thought, well, who cares? I'm not going to use them. No one else is going to use them. We are fine. Then I found that some other devices might be useful. For example, a device that allows you to control non-smart stuff in your house. So you just control the power socket, and you can turn them on and off. Or a smart keychain that warns you if you are getting afar from your keys, or you are forgetting them at home, or you can know where they are whenever you want, because they are connected to the internet. So you have a keychain that knows where you are, every time knows where your keys are, that knows if you're afar from your keys, and also knows where you live, which is something that should be protected somehow.
But still not really security critical, right?
Yeah, not security critical. Like thermostats are not security critical. They're useful. They shouldn't be hacked into, but they're not security critical. But then there's that. Cooperative robots. Robots that work with humans in front of them, that have the power to smash them, and that shouldn't do that. At least they're not supposed to. And insulin pumps for diabetics, or also cars. Nowadays, your car has more lines of code than your desktop PC. And that is something that we should think about in a security-oriented way. And also, you don't want a robot that has opened you and is fiddling inside you to suddenly blue screen. That's something that shouldn't happen, but most of those things run outdated software and are connected to the internet because it's now cool. So we tried to analyze a little bit of threat model. What you see behind me is a screenshot of all the devices that are considered IoT, and this is an enormous number. All those things are connected to the internet, exposed, and can be accessed directly. There is no firewall behind the internet and them. That's just the thing, and it is exposed. Since we do security-related stuff, consultancy, and code review, I had to look inside those devices and see the code. Well, I saw some bad things that I didn't expect, because those were like in your course of security, computer security at university, and they were the example of something that you should not do.
And he was laughing. It was laughing at me. I can tell you, it was laughing at me, saying, "Oh no, these things do not happen in the real world. That's just university examples."
Well, they stopped happening for a while. They just came back. So what you see behind me is a code with the comments saying, print the required string into the destination in a protected way. Because the programmer remembered that if you don't use the SN printf, you can have buffer overflows. So he put an N, which counts the buffer size so it doesn't overflow on the buffer. But he or she forgot that there should be a format string as a third parameter, and the string should be in the 4th position, which makes this a format string vulnerability that allows you to have remote code execution. And in this case, it was a thermostat. So not that bad, I guess. But then I saw something worse, which is this piece of code, which used to run on a POS device. So these reads credit cards. And it kept reading a character and putting it into a buffer without ever checking the buffer size. So it's just a plain, normal, average buffer overflow that you can find in any example of what not to do. And the most amazing thing is that this could have been a function call. This is just an fgetS rewritten to make it vulnerable, as an exercise, I suppose. But let's stop for a second and think. A thermostat and a POS device is completely broken, and we could take control of them. But those things do not usually hurt you that much. I mean, they can steal all your money, but there's just that. But then we found this.
Yeah, sometimes IoT devices are not small and cute. Let me introduce you RB140, Robbie for short, if you are a fan of Asimov. It's a 1 ton, more or less, device that is controlled by computers. And one day I was sipping a coffee with a colleague that works on this device, and I was saying, I wonder how those computers are connected to the network. And they were so happy that they basically showed me all of the connections. And then I thought, OK, so let's do what every single engineer does before using a device. Studies the manual. That's one of the telling signs if you are an engineer. You study the manuals. The other sign is that you take apart your Legos and build other things. Those are the 2 telling signs that you are going to be an engineer, and that's kind of a curse. So we studied the manual, and this is the manual. It reads, all controllers, controller is a shorthand for robot. All controllers have a default user named default user that has a publicly known password, robotics. The default user cannot be removed. The password cannot be changed.
So it's like, you can't win.
You can't tie.
You can't tie, and you can't stop playing.
Exactly. Now, to be honest, in modern robotware software versions, this can actually be removed. But it's still there by default, but it can be removed. The point is that most robots are not like computers. A robot like the one I showed costs about 100,000 euros. You buy it, and then you keep it in service until it falls apart. You don't change it. And the computers that are connected to the robot cannot run, to that robot that I showed you, cannot run this version of the software because they are too old. So if a company is faced with the necessity of upgrading a computer because they need to upgrade from Windows XP to Windows 10, you already know that that's a decision that is going to cost a lot of time and a lot of discussions to the CISO to make it happen. But if you go to your managers and say, OK, we need to upgrade all of our robots because we need to remove a password, they are going to just kill you and bury your body somewhere and pretend like it never happened before.
Or they can have the robot kill you.
Yeah, precisely, even from remote. So, so automation engineers are better engineers than computer engineers. They tend to think about things that can go wrong and act upon it. So when an automation engineer programs a robot, they develop the code in an environment that contains the code that runs on the robot so that they can check exactly what is the effect of the code they write. In order to make sure that this is the same environment that is on the robot, when you upload your code from a development studio to the robot, also all of the firmwares of the robot are updated to the exact same version that you have on your laptop. They are kept updated in order to make sure there are no mismatches. So when we were looking at it, the robot contains a number of computers. But when you update your code, you connect only to the main computer. So we asked ourselves, how do the other computers get updated?
And we shouldn't have done that.
No. The answer is that they download everything, their firmware image, via FTP locally. And yeah, that's FTP without the S, because the S stands for secure. And it's the same reason why in IoT there's no S. They download this code, and it's not signed. It's not even checked to see that it's actual code.
And bear in mind, this is not just a normal FTP server. This is a custom implementation of FTP, because we didn't have enough implementations of FTP around.
They rewrote their own FTP server for doing this. So it retrieves, any component of the robot retrieves the software from this FTP repository that is also exposed to the outside with the default password and user that you saw before, of course. And so we said, yes, now I understand why they have a default password that you cannot remove. It must be the password that the other components of the robot use to download the software.
Which would be bad enough.
It would be bad, but it would be a bad decision that has a kind of a reason. Bad reason, but still kind of a reason. But it's not like that. Fortunately, it's not like that. No, the robot, when it boots and it updates the software, it just turns off authentication for 5 minutes. For 5 minutes, any user and any password works internally and externally on the FTP server, on the APIs, on the web services that the robot exposes to the world, on everything. But that's just for 5 minutes after the robot has booted. So it's not a big problem. And then you ask yourself, OK, how the hell do the other components that are inside the robot get all of the configuration parameters that they need to work? And you look at the traffic on FTP, and you see this command. They get from the main computer this file from the /command path. But on the main computer, there's no /command path. It's a virtual path that has been created inside the FTP server that they've rewritten for themselves, so that if you retrieve certain files from that virtual path, they contain information. And if you store files in that virtual path, they execute commands on the underlying operating system of the controller directly.
Before you start screaming, it gets worse.
Yeah, because then you look inside the code. This is actually decompiled code. Because they compiled the code with all the symbols, they didn't scramble it, they didn't pull anything out of it. Everything is just as it appears. And inside the code, there is this sprintf that is a beautiful textbook buffer overflow, which, since this robot is running on an operating system, Vixx, which is designed to run industrial controls, it's not designed to run code that is open to the internet. Well, Vixx does not implement ASLR, does not implement stack protection, does not implement any of the security features that we are used to in our modern world. And so this thing can be...
And there's more. Everything runs as the root user.
Yeah, of course. There's no distinction of users. That goes without saying. And it's just a robot that weighs a ton, after all. What can possibly go wrong? And so this command, there's basically 3 buffer overflows in 2 lines, actually. It can be exploited as Aleph-1 exploited stuff in this 1994 paper, exploiting the stack for fun, smashing the stack for fun and profit. You can literally textbook apply what he wrote there to here, something that you cannot do on any modern machine ever, and exploit it. I was able to write the exploit. That must count for something. So this is basically a vulnerability matryoshka. Now, since the talk is zombie-themed, I want you to appreciate the fact that we were able to find zombie matrioskas to put on this slide. This is an actual product that you can find on Amazon. If you search for zombie matryoshka, you will find this one.
Yeah, they're not a sponsor of it.
No, they are not a sponsor of the talk, unfortunately. So now the good thing is that these robots should not be connected directly to the internet. There's firewalls in front of them. There's things like this. This is an industrial firewall, which means that it's a shitty router that costs 8,000 euros. And this is not the firewall that this vulnerability refers to. I need to point this out. I just took an image just to show you what type of device this is, but this is not the same.
Yeah, because the original one isn't patched.
Because the original one isn't patched, but let's not get ahead with that. So there's 85,000 of these devices that are exposed to the internet, which is good. It's not good, but it's right. It's their job to be exposed to the internet and to be fiercely defending the robots behind them. Except 5,000 of these 85,000 do not have passwords set. And we have not tried with the default passwords. This has no password at all. So even if they do have passwords, we decompiled some of the code on these devices. And the protection interface of the devices is written in PHP. And that's a piece of the PHP code that runs on one of these devices.
You know what? Why would you run an interpreted language on a dedicated hardware?
And PHP in particular.
Well, yeah.
Yes. So, and if you look at that piece of code over there, the last line where basically it picks up all of the get and post parameters and slams them in memory without checking them and uses them for doing stuff. If you ask me, what is the vulnerability in this line, I would say, I don't know, everything. Every single one of them, because that's basically wrong on all counts, on all single counts. And so since we saw this code that is so wrong, we said, well, no human can willingly have put this line of code inside here. So we searched for it for the line of code with Google. And guess what? It wasn't a create this API with PHP post from 2009 that the author of the post had the good idea of removing from the internet because it was awful, and we found it on the Wayback Machine. So we informed these guys that they had this dead code that was basically grasping at their user from the grave inside, and nothing. And then we said, well, you know, we disclosed this publicly. And they were like, oh, you didn't tell us. And we showed them like the 12 emails, 4 of which with the guy that told us you didn't tell us, where we tried to alert them to the problem. Then we gave a talk about this at Black Hat in the US. And and I didn't even realize it. And they showed up after the talk, gave us their business card, greeted us, and went away. But the down firewall is still not fixed. So I don't know exactly what I need to do with their business card, but since we're in Amsterdam, we may find some uses for that.
Whoa, okay.
So the problem is that 1980s are calling, and they want their vulnerabilities back, because it's time that these things are laid down to rest. So we decided to do a brainstorming, since this is a talk about zombies. Brainstorming seemed like a sensible thing to do.
He really wanted a slide titling Brainstorming.
Yeah, basically this is the slide the talk is about. And we discussed this on Twitter, engaged with the community, tried to do live interviews with embedded developers, tried to figure out what is the root cause behind these vulnerabilities. You'll never guess what happens next.
So when we asked the community, why do you think this happens and how would you fix it, we went out and talked with people. Some of them were lead engineers that code that stuff. And while we were talking with them, one of them asked us, wait, stop. What's wrong with the scanf? What's wrong with smprintf and string copy? They're standard library, so it should be safe, right? And that's where we just stopped, made a step back, and we realized there is no awareness whatsoever. People that have worked into the electrical engineering stuff for a long time have missed the step where we started telling people that they should write secure code.
Also because vulnerabilities are something that happens to others for them. They happen to the web guys. This is the literal phrase that one said, well, but you know, vulnerabilities are stuff that happens to the web guys, not to me. I write embedded code.
They do not expect their code to be exposed. And there's more. Some vulnerabilities are just back because IoT runs on very limited hardware. Out-of-memory exception is something that we as developers are not used to see anymore, unless you are coding on something that has just 2 kilobytes of RAM. In that case, that's going to happen, and you have to handle it. You have to take care that your malloc returned as a null pointer.
And on the other hand, whenever you suggest a solution, we as security experts, living in the world of machines with very large computation capabilities, we tend not to think that some of the security features that we take for granted just do not exist in there because they just require too much power or consume too much battery power.
And there's more. Those things run really old code, firmware code that has been certified and cannot be changed without re-going through the whole certification process. So there is legacy code that can't be changed, and there is the market pressure, so the last thing you're going to prioritize is having the code patched and recertified to launch on the market your last hairbrush that tells you you're beautiful today. So when that happens,
He's really pissed off at that airbrush.
Yeah, come on. So the whole point is that we couldn't find an easy solution, and the community, the security community, didn't help us finding proper ones. And even the easy one that should be there were not there. So countermeasures have been out there for a long time for buffer overflows, out-of-memory exception, heap, smash. Everything has been there, but not on IoT. So when you look at how the kernel runs on an IoT device, there is no segmentation protection. There is no ASLR. Writable code can also be executed. And all the patches, all the security patches for the kernel are just not there. And there is no good reason for this, because those features do not use power, do not use memory. The memory they use is just too little to justify not having that. And also, GCC. How many here have used GCC in their life? OK?
We had a Codemotion. We kind of expected that.
OK, GCC has default behaviors that should behave the same way for every platform and operative system combination. And it does, except when you're building for Linux, for ARM, which is like 90% of IoT. And in that case, it disabled stack canaries protection, stack smash protection by default until last November, for no reason at all.
Just in time to trash the first edition of this talk for for Codemotion in Milano.
Yeah, they just changed it like the week before.
Like the day before.
So we tried to use some SDKs, and with the default configuration, build the code, vulnerable code, but just to see the features, the security features built in. This is an output of checksec, which is a tool to check how many and which security features has been enabled for the executable. There is no railroad, no stack canary, and X is enabled, well, thanks, but if the operative system doesn't support it, it's useless. And there is no Pi. So there was just no default security configuration, so we started looking for it. We spent something like 2 hours trying to look any security configuration in the editor. We couldn't find any, but we found a quality improvement tab, which was a subtab of a subtab of a subtab. And we finally found stack protection. So we enabled it, and we were amazed and terrified of what we were asked about. Stack protection should generate random values at runtime that an attacker cannot guess. The
That's
IDE,
the random value, right?
the
over there.
IDE was asking us for our canary value, which was embedded at compile time into the executable, which rendered it completely useless.
And
So-
I'm sorry, just look at the slide. Is that a
the zombie canary.
over
Yeah.
there? Okay, okay. Fair.
This is a very poor implementation of a canary that just makes it useless. So even if we wanted to implement security features, we couldn't.
I hope it's clear that we are laughing in order not to cry too much. So the point is that we have a community, wide community of developers that have kind of missed the train on network connectivity and missed the train on web connectivity. But now, their devices, the ones that they have been used to program this way for a very long time, these devices are behind our web applications and they are connected to our network application. That's what the IoT is about. And these people do not really think vulnerabilities happen to them. They happen to other people. We have completely missed them in our evangelism or in our discussions of vulnerabilities. And the point is that when you look at their behavior and you ask yourself and you ask your peers in the security community, how do we help these people produce a reasonably secure code? Like, let's take out the low-hanging fruits. Just the low-hanging fruits, just the simplest things. Well, guess what? We have not produced anything that can be given to them. There's no IDE tools, there's some, but they are not the tools that they are using. There's some IDE integration, for instance, in Visual Studio Code, that will help you while you are typing your code. If you are making an obvious security mistake, they will tell you, are you really, really sure of what you're doing? Because this looks like a format string.
Yeah, but
This looks
sorry.
like...
Who here compiles the code in a way that errors do not and warnings do not make the code compile? Because who here has always written code in a way that just also warning don't make the code compile? That's crazy. Yeah, it's like a couple of times for what you really needed to work, but that's not the average way you work.
Yeah, and also, there's no real way to perform security testing for these devices, even if you give it to people like us. It's often difficult. I mean, if it's the airbrush, then it's reasonably easy to have one. But if it's a robot, it's difficult. We were the first one to actually write and design tests for that robot, and that's because we happen to have one at the university. But otherwise, it's difficult to have one to test, one that you can actually not really break, because they would break my bones, but you can risk making it misbehave. There's no tools in our armory that are targeted to what developers do. If you ask a security person, how do we help embedded designers to write more secure code? Our usual answer ranges from get them to write in Rust to get them to write in Go. Everything except helping them writing in the only language that they are ever going to use, which is C. In the only IDE that they are ever going to use, which is something like this. This is Texas Instruments IDE, which is a great IDE for writing embedded code. It is used by a lot of people. Now, that function that you see over there is a straightforward buffer overflow that every single tool in the world for catching buffer overflow will just smack you with your code for writing it.
Yeah, Apple has patched their standard lib so that if you write that code, every time that function is called, it's gonna print in standard error. Do not use getS. They patched the standard lib to warn you at the compile time, so that function is gonna warn the user, not just the
This
writer.
is the compilation of that code with every single warning that the IDE of Texas Instruments can offer enabled. And there's nothing about that. And this is the same with this string copy that is a statically evident buffer overflow. We are copying 100 bytes into 10 bytes. It's statically evident, no way to miss it. And this has all sorts of warnings, including the ones by Misra C. And the ones by Misra C are telling you, oh, you shouldn't be using those values before initializing them. And you should really not be using the standard library. That's what it worries about.
Let's just stop for a second and think that in this conference, people are talking about serverless stuff, advanced Lambda function, and we are talking about buffer overflows in surgical robots. Just for a second, think about how big is the gap between these and that.
And also, what we found is that while the SDKs have examples, and these examples were reasonably vulnerability-free, with a few exceptions that I'm going to show in a moment, most of the SDKs had hidden assumptions about how the code would work. So if you as a developer, maybe not experienced, or maybe with no experience of security vulnerabilities, took those examples and changed them to do something slightly different, you would take away those assumptions and not even know about them because they were not written in the documentation.
And not even in the same function.
And not even in the same functions. And then, of course, there were also vulnerabilities like this beauty here, which would just take something from the command line and smack it inside a variable without checking the sizes. So this is a straightforward buffer overflow, and this comes from an SDK. Or, well, do you really want to talk about this one? Because I think you have an affection for this one.
Well, yeah, you know, JSON looks like a simple format to parse and to write. It's not. Do not try to implement your own parser or serializer like this one. Because this is not a JSON serializer. This is just danger. This is a dangerous thing that you shouldn't put anywhere in any way. Because if anyone, and we could, can get control of any of those variables, they can reformat the JSON. They can change the fields. If they add a redundant field, the JSON parser on the other side has to choose which one of the two fields are going to be read and set in the dictionary on the other side, which means that if an attacker can duplicate a field, there is a good chance that field is going to be the one recognized on the other side and not yours. And that fails in a silent way. So we asked for tools. And what we got from the community is something that you couldn't use, shouldn't use. How many people here have used libfuzzer or AFL? Yeah.
Sorry.
I'm sorry. Is that easy to configure and make run? Very straightforward. Yeah. Sometimes it takes me like a couple of days to configure the whole thing to just run and test and find potential vulnerabilities. And then there is Concert C, or to change the language to a new language, a different language, or address sanitizer, which is a very great tool if you want to check your code, unless you're writing for Linux ARM because it's not supported. And
it's beautiful. You have the table of supported configuration for ASM that everybody uses to check their, I think most people have in their pipeline to check their code. And there's just one missing supported configuration in the matrix, which is ARM and Linux.
You could write IoT there.
Yes.
Just so let's just leave that aside and think about solution, like stuff that we could do. And this is where it gets funnier. They told us
sort of way.
In a sad sort of way, yeah. That kind of funny things you should never do. Let people choose their analysis tool. We are two security experts. We couldn't find any applicable one. So how can someone that has no security background choose their own tools? That is just madness.
But that's easy.
They don't.
No, they just need to start from threat modeling their problem. After they have threat modeled their problem, considering all inputs of styles and designing all the things that can go wrong with their code, they can start thinking of the tools that they need and to start thinking of the language and of how to redesign their processes.
The time it took to just say that is too much for most companies.
Yes.
So
obviously, no developer ever is going to do threat modeling of every single device they run code.
Or assume any input is hostile. There is no way you can assume every input is hostile. Like if you're writing a thermostat code, you don't want to assume your thermometer is giving you fuzzing input, is fuzzing your code, because that's not going to happen. And then it got even worse, because those solutions were just, wow. Apply langsec to everything, which is just madness for most coders, or look at the assembly input. Because when you compile your code, the compiler might screw it up, and mostly if you're writing crypto code.
That you shouldn't be writing in the first place.
To which my answer was, wait, why are you writing your own crypto? And why are you looking assembly? Why are you using a compiler? Why don't you compile it yourself? So that's not something you can ask programmers to do. And the last one was pretty funny because they told us to patch the syscalls so that they behave in a different way, in a more secure way. Who here has ever patched the kernel, the Linux kernel? Was it fun? Yeah.
Lots of fun.
The same kind.
Days and days of fun.
Yeah, the same kind of fun we were talking about earlier. So yeah, we were puzzled, and once I saw a guy try to close a port, a network port, and I was reading at the code and I couldn't find how they were closing the port. I was testing the device, I saw that the port was closed, but I didn't know how. And I read the code and I couldn't understand how, and then I realized there was a syscall with a code that I didn't know before the code closed the port. So I was like, did you really patch the kernel, add a syscall, add a custom handler for that syscall to close a port? That's what they did. They patched the kernel to just stop listening on a port, to which they did wrong, so they had a problem with memory allocation at ring 0 in their code, which is not good.
I don't know how that happens. If you touch the kernel code and that stuff at random, how it happens that you...
Oh, yeah, that's so easy to do, right?
Yeah.
So
easy peasy.
Yeah, we found some solution that we can suggest. Do you want to?
Sure. So the solutions that we found that are applicable in our opinion, and that we tested with colleagues working on development. In some cases, you can create or use really some safer libraries that can do things such as handling type safety, handling truncation, and so on and so forth. There's some. The problem is that in some industries, there are standards that forbid you from using external libraries, which
because they're unsafe, right?
Because it's not, but that's because of safety. And on the one hand, you understand it. You need to write all of the code so that you are responsible for all of the code base that runs on the device. On the other hand, from the security standpoint, reinventing the wheel is kind of the worst thing that you can force a programmer to do.
Reinventing the wheel is generally a bad thing.
Yeah, in general, but in security in particular, it's awful. So MISRA C and the JPL Conde standard that are widely applied already have a number of things in there that kind of help in writing more secure code. Not really completely, and they are not applied everywhere. They are applied in the automotive and avionics sector mostly, but they kind of help. There are some cheat sheets. And as a community, the security community shies away from cheat sheets and lists because we know that security is more complex than that. And we love to look at things in their depth and in their complexity, and that's fine. But we need to give the guys that are coding...
At least it's something.
Yeah, at least something that they can use to avoid making the most common mistakes, if nothing else. Here on the slide, there's a number of resources.
Here's some more. If you want, the slides are already online. You can check on Twitter. We replied to the tweet with a link to the slides.
There's already the link online. There's tools that actually work also in the embedded context. CLang, for instance, can be used in the embedded context most of the times. Site tools, CPP check, Flow Finder, they kind of work. They already find some things. they can be injected into a pipeline for building code. You can check if you have enabled Stack Protector for
Please
all
do.
the code that you have built in the last 15 years, while this was off by default. Yeah, I'm sorry. And while I'm talking about code that you built in the last 50 years. If you inherit a code base, there's a number of things that you may want to do when you are digging into the grave.
I'm sorry, by the way, if you have to do that.
Yes. So you can go and lint the code, try to set it up to modern standards, and see if that alone takes out some interesting things. There's things called the to-do documentation, if there's any.
Fix me.
Fix me.
Most of bugs
ticket.
lie around a fix me statement.
Yes, yes, indeed. Inputs and outputs, the usual things. But also seek for custom crypto code and kill it with fire. That's one of the best things that you can do to improve the security of old code bases. We have a series of books here. If you need to survive the zombie apocalypse, this is the right book for you. If you need to survive the IoT vulnerabilities apocalypse, this is the list of readings that you may want to do.
Do not mistake that one
Do
for
not
another.
mix the two. And so, in conclusion, in our research in IoT security, we found that a lack of awareness is there, even if we don't understand it. Because as security people, we keep talking to each other. And we are all aware of the things, but other people are not. Surprise. Lacking tools, lacking the processes. And we found some ways to aim for the end, but as a community, we need to build more tools and more processes that can actually be applied by our colleagues building embedded stuff. Thank you very much for your attention. We can take questions right now, maybe if there's a few minutes more. And then we will move to the huge igloo-like structure, and we can continue the discussion over there.
Thank you.
Questions? No one? Yeah, there's one. Yep. Let's see if it works.
Maybe it's a little naive, but wouldn't it be a great progress if people stopped using C and use some other language?
Yes. Yeah, the short answer is yes. Using a memory-safe language would be the best solution for most of those vulnerabilities. The problem is that most of those environments do not support different languages. The compiler compiles for a custom architecture. So those languages like Rust or Go, which are the most widespread ones in IoT, do not compile for those architectures or operating systems or stuff like that. And also, how do you retrain a mechanical or electronical engineer to use a different language that he has been using for the past 25 years? He is not a coder. He's not a developer. So that's hard.
Yeah, the problem is that in many of these instances, the people that are writing code have a different sort of background, and they need it, actually. And so they are trained to program in that specific environment and with those specific tools. And those tools sometimes are the only way to make code to compile code that ends up on the specific device. So if you are using TI stuff, it's not impossible to do it otherwise, but most people will use TI's toolchain for that. So unless the language ends up in that toolchain, and it's not going to happen, we are not going to be able to make them.